Divisibility Rules Part 2. Hello friends, today I'm going to be basically doing a continuation of this video by Michael Stevens on the Ding channel. Michael Stevens, as you know, is Michael from Vsauce 1, not Vsauce 2 or Vsauce 3, which is Kevin and Jake, I believe. Um, but this is Michael from Vsauce 1. He made this video 4 years ago, and I watched it when it came out, in fact. But I never did a follow-up on it, and today I'm going to be doing a follow-up on it. So here we go. That's my calculator. Ignore that. WordPad. So, um, this is the ones that work for all real numbers. There's quite a few that work for all real numbers, and there are some, well, for all real integers, I guess I should say. It works for all integers. So I'll do that. Works for all integers. So, um, but there's a handful that I found out that only work for less than 1,000, which still though less than 1,000 is pretty good. But I want to clarify this at different levels. So, um, in the original video, as you can see here, he does ABC, and A being the 100th place, B being the 10th place, C being the ones place, tens, B being the tens place. Yeah. I said that right. And I wanted to keep that, so I added a Z in front for thousandths place. So here we are. So uh, ZABC divided by 1 is all real integers. Any real integer divided by 1 is indeed divisible. ZABC divided by 2 is all even numbers. Technically even integers, but you know what I mean. If it's even, I mean, even integers is like kind of a redundant point, right? Because if it's even, then it means it has to be divisible by 2. Like that's the definition. So, yes, whatever the number is, it could be 2, 5, blah, 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 blah. Duh. But if it ends with an 8, which is divisible by 2, that means that when I divide it, it is going to be a whole number. So there you go. ZABC divided by 3 is if the sum of all numbers is divisible by 3. So let's take, for example, 1, 2, 3, 4, 5, 6. What is 1 plus 2 plus 3 plus 4 plus 5 plus 6? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, 21 is divisible by 3, so divided by 3, it is indeed a whole number. It is a whole number, which means it's divisible by 3. So ZABC divided by 5, final digit ends with 0 or 5. So it doesn't really matter what the number is. It can be, but if it ends with 5, that means that when I divide it by 5, it's that. But it's a whole number, which means it's divisible by 5. And if I subtract 3, then I get this number, divisible by 5. Yes, it is, whole number. So there you go. That's 5. Divisible by 6. If a number is divisible by 3 and is even, aka it's divisible by 3 and 2, that's another way of wording it, is divisible by 3 and 2, then it is divisible by 6. So let's go back to that example earlier. 1, 2, 3, 4, 5, 6. Is it divisible by 6? Well, we already know it's divisible by 3 and it is indeed even. So yes, it is divisible by 6. And ZABC 9, sum of all numbers is divisible by 9. So it's very similar to the 3, except they have to be divisible by 9. So let's say, for example, 1, 2, 3, 4, 5, 6, 7. I actually don't know if this is off the top of my head. So that would be 21 plus 7, which is 28. This is not divisible by 9 because 28 is not divisible by 9. So as you can see, it's not divisible by 9. So let me come up with an example that is. I don't know. 4, 6, and then 6. This should be divisible by 9. And indeed it is. There you go. Oops. And if it's divisible, if the final digit is 0, it's divisible by 10. Don't think I need to explain that one to you. So these are the ones that are a little bit more complicated. These are the ones that were featured in the video. If a number is, if you add, multiply the tens digit by 2, which I'm going to just for the future reference, I'm not going to say tens digit, hundredths digits, hundredths digit, thousandths digit. I'm going to say Z, A, or B, or C, right? So just so you know for future reference. So if we multiplied 2 by b, or b by 2, and add c, then we'll be able to find out if this number is divisible by 4, then we'll know if the entire number is divisible by 4. So let's take the number 184, for example. There's no thousands digit, so we don't even need to worry about that. So 0 times 1. Oh, by the way, the reason why this works, let me explain. Actually, I take it back. Let's take it back a step. What is this? How does this work? Why do we know this works? Again, this was in the original video, but I'll do a really quick, brief explanation. So this is a representation of this number, right? 1000 times z, 100 times a, right? Because these are all the different digits. So this is the same as this. Is it? Yes, it is. So had to double check. So 1000z plus 100a plus 8b plus 2b plus c. Now, why did we do this 2b plus c? Well, that's because we want this entire thing to be divisible by 4. And this entire thing right here is divisible by 4 indeed. This right here is divisible by 4 via 2, but this one via 25, this one via 250. So we know that this entire thing is divisible by 4. So that means that only if this entire thing over here is divisible by 4, then we're good to go. We don't need the 0, or we don't need the a, and we don't need the z, because the z is over here and the a is over here. So z and a are always going to be divisible by 4. So let's do an example right here. 184, right? 0 times a is 1. This equals 0. 2 times b is 8. This equals 16. C equals 4. I was about to say 14, but no, it's just 4. So 0 plus 16 plus 4 is 20. 20 is very much divisible by 4. So next up we have 8. Honestly, I should have done a different number. And in fact, I will do a different number in real time. Let's get a different number in real time. So let's do 8 times, I don't know, 91 times 5. There we go, 3640. So let's do the numbers 3640. Okay, is 3640 divisible by 8? Obviously it is, because you just saw me calculate it, but let's prove it. How about that, right? So 3 times, 0 times z, and z is 3, is equal to 0. 4 times a, in this case a is 6, is equal to 24. 2 times b, in this case b is 4, is equal to 8. And c is equal to 0. So we're going to have 0 plus 24 plus 8 plus 0. And as you can probably already tell, it is indeed 32, which is indeed divisible by 8. It is 6 times 8. So there you have it. Now, this is outside of the video. Next step, I came up with this myself. We have 16. 16 is also always going to be in a situation where it is, where it can be divisible, where you can prove its divisibility. And the reason why is because you have 2000 divided by 16, which is a whole number. So if we multiply this whole thing by 2 to get this number, then we're chilling. Let's also keep in mind, my friends, that, what number was it? 10,000? 10,000 is also divisible by 16, sorry. And it is 625. So there you go. But we're just doing ZABC for the time being. So we're going to multiply this whole thing by 2. And that's going to give us 2000 plus 200A plus 20B plus 2C, okay? And the reason why we're allowed to multiply this right here, by the way, is because this doesn't change. Multiplying this doesn't change whether or not it's divisible by a certain number, right? If you multiply a number by 2 or by 3 or by 4 or by 5, it doesn't matter. If you multiply that number, that doesn't change whether or not that number is divisible by your original intended number. So in this case, 16. You can take whatever number you want, and if you're asking, is it divisible by 16, the answer doesn't change if you multiply it by 2. As long as you don't multiply it by itself. Because if you multiply it by 16, then that's a self-defeating cycle. So, there you go. 2000, 2000 Z plus 200A plus 20B plus 2C. That's what we have here when we multiply this whole thing. So, as I just proved, 2000Z is already divisible by 16, so we can just leave that here. 200A, well, that's not divisible by 16, but 192 is. So if we take 8 out, we can leave it here on the left side. So there you go for that. 20 is not divisible by 16, but if we take 4 out, we can stick it over here on the side. 2 is obviously not divisible by 16, so we're going to leave it on the side over here. So now we're left with 8 plus 4, 8a plus 4b plus 2c. And on the remainder over here, this is all divisible by 16. So now with an example, okay, never mind, I deleted the example by accident. The example was 1552. So 1 times 0 is 0. 8 times 5 is 40. 4 times 5 is 20. And 2 times 2 is 4. 40 plus 0 plus 40 plus 20 plus 4 is 64. And 64 is indeed divisible by 16. So there you go. Now, we're actually going backwards. We're doing divisible by 15, because I feel like that makes more sense to talk about 8 and then 16, because these are very similar, right? Like this right here is literally just this, but multiplied by 2. But you have to multiply it by 2 in order to actually check and see if it's divisible. So now we have divisibility by 15. Well, divisibility by 15 is very simple. You just simply find out if it's divisible by both 5 and 3, because there's no instance where you have a number that's both divisible by 5 and divisible by 3 where it's not divisible by 15. So divisible by 5, like I said, any number ending with 5 or 0. Divisibility by 3, we already proved this earlier, so here we are going to take out the Z, the A, the B, and the C. So now we have 999Z, 99A, and 9B, which obviously all of these numbers are divisible by 3. So if this part right here is divisible by 3, then this over here will also be divisible by 3. So let's take the number 1350, for example. Is it divisible by 15? Well, it ends with a 0, so it's divisible by 5. Is it divisible by 3? Let's add all the digits together. 1 plus 3 plus 5 plus 0. That is 9. And 9 is indeed divisible by 3. And I do make sure to clarify, you might be looking at this like 9, that's not divisible by 15. That doesn't matter. All that matters is that it's divisible by both 5 and 3. So because it's divisible by both 5 and 3, then it is divisible by 15. And last but not least, for numbers that work for all numbers, we have 18. So to find out if a number is divisible by 18, you just simply have to find out if it's divisible by both 9 and 2. I'm saying the word divisible a lot. So if it's divisible by 2, pretty straightforward. It's just any even number. So, and if it's divisible by 9, it's just sum up all of the digits together, and if it equals 9, then if this side equals 9, then it's divisible because this side will always equal 9. So my example here was 1638. Why is this? None of this is right. I guess I didn't update it, because I did change some of the numbers around, so my bad. There we go. So 1 plus 6 plus 3 plus 8, that is 18. 18 is divisible by 9. And because this number is even, we know it's also divisible by 18. So that's it for all of the stuff that is always works for all integers. Now we're moving on to territories of numbers that only work for less than 1,000. And the reason why is because these numbers in particular, they cannot ever be divided by a number that is divisible by well, that has like 1 and then a bunch of zeros. And the reason why, if you can take an example, right? So why does the 8 work, right? Well, the reason why 8 works is because even if you do 10 divided by 8, it is not an irrational number. It's a rational number. It's a fraction. It is 5/4. So you know that eventually you'll be able to get to a point where you can do that. But it doesn't work for 7 because 10 divided by 7 is an irrational number. You will never be able to get to a point where you will have 1 followed by a bunch of zeros and that number being divisible by 7. It'll never happen. Isn't that tragic? Same with 17. Um, 1000 divided by 17, again, irrational number. It goes on forever. You will never have a number that is just 1 with a bunch of zeros behind it, and it is divisible by 17. So I decided to make an arbitrary cutoff point of numbers that are divisible by less than 100. I could do more. You could choose like less than 1,000, less than 100,000, less than a million. But I chose, for simplicity's sake, to do just less than 1,000. So, um, and again, there are methods you can do, like in this very video here, there is a method you could do that is a little complex that where you like concatenate to the tens place and then multiply the final digit by c and you add that together, and he explains in the video why. But we're not going to be doing any of that magical nonsense. We're just going to be multiplying the digits that already exist and adding them together. But like I said, of course, the limitation is this only works for numbers less than 1,000. So here, these are all the digits that are divisible by 7 that are less than 100. So we have right here 100A, 10B, and 1C. In order to get the numbers we want, we don't need to do anything. We can just keep it as is. We're going to not multiply anything, and we're going to do 2A, 3B, 1C. Why? Because if we do 98A and 7B, both of these numbers are divisible by 7. So all we need to do to get to a point where we have the numbers we want is to take out 2 of the A's, because 2A plus 98A is 100, 3 of the B's, because 3B plus 7B is 10B, and 1 C. So if this right over here is divisible by 7, then the whole number is divisible by 7. I think you get the idea. So let's take the example number of 217. 217, is it divisible by 7? Let's find out. Let's take 2 times A plus 3 times B plus C. 2 times A being 2 in this case, is 4. 3 times B in this case being 1, is 3. C is 7. 4 plus 3 plus 7, 4 plus 3 plus 7 is equal to 14, and 14 is indeed divisible by 7. So there you go. Now let's do 11. I came up with all of these right here, by the way. All of these ones I came up with just by trial and error, basically. I made another video that might be, I don't know if that video is going to be in the description or not. I don't know if I'm going to upload it. It's like an hour long where I figured all this stuff out myself. I'll probably upload it, but we'll figure it out. It'll be unlisted though, that's for sure. So right here we have 100A, 10B, and C. Well, here's a problem. We'll never be able to get C to be divisible by 11 because C is less than 11. Or at least it could be less than 11. The integer number in front of it is less than 11, or less than 11. Which, again, like, yes, it wasn't really that much of a problem here, but B, for example, like, what am I going to do with B? So B, 10, this is less than 11, so that's where I'm screwed. That's what I really meant to say. I don't know why I said this. Now, of course, there's a complicated way I could do it otherwise, but it's just a lot simpler if we just multiply the whole thing by 10. So now we have 1000A, 100B, and 10C. So that will give us 10A. Well, if we take out 10 and take out 10A and take out 1B, then we have 990A and 99B. So 100A plus 990A, that is 1000A. B plus 1B plus 99B is 100B. 10C plus, well, there's no C over here, it's just 10C. So here's our example. 341. Off the top of your head, can you tell if this number is divisible by 11? Of course not. You're not weird. So 10, here's how we do it. 10 times A, which in this case A is 3, is 30. B is 4, pretty straightforward. And then 10 times C, which in this case is 1, is 10. 30 plus 4 plus 10 is 44. Very straightforward. We can do another example. How about 500 and, I don't know, 83, right? Is this number divisible by 11? Probably not. Well, let's find out though. 50 plus 8 plus 30. I'll show the math here just to show you. I know it, but 50 plus 8 plus 30, 88. 88 is indeed divisible by 11. So there you go. Isn't that neat? Um, ABC divided by 12. So how do we do it when it's divided by 12? There's honestly probably is a better way to do it, but the problem is that actually, wait. If it's divisible by 3 and divisible by 4, doesn't that work instead? Hmm, I wonder. This is the system I came up with, but I wonder. I think if it's just divisible by both 3 and 4, that would work. I'll test that out later. Well, let's do what I have written down, and then we'll go from there. So, how do we get to where we want to? We can multiply this by here by 2. So now we have 200a plus 20b plus 2c. So now we can take out 8a, so 192a plus 8a is 200a. 12b plus 8b is 20b, and then there's the 2c right there. So as an example, for the number 252, we have 8 times 2, which is 16. We have 8 times 5, which is 40. And we have 2 times c, which is 2, which equals 4. So 16 plus 40 plus 4 is 60. So now that being said, let's think about this, right? 252. It's divisible, we know it's divisible by 3, because 2 plus 5 plus 2 is 9. Is it divisible by 4? 2b plus c. 10 plus 2 is 12. 12 divided by is divisible by 4. Yeah, that is a way better method. This method is stinky. Huh. Yeah, I'm a little bit of a fool, because I can just do 12. Oh, I could have kept the 60 as it turns out. 60, 72, 84, 96. And it's divisible by both 4 and 3. Yeah, that's way simpler. I don't know why I didn't think of that first. Sometimes, you know what though? Sometimes you just don't think of things. So ZABC divided by 6. No, 4. Sorry. No, we'll do 3 first. No, we'll do 4 first. No, we'll do 3 first. 3 is A plus B plus Z plus A plus B plus C. Right? That's this shenanigan right here. I didn't mean to do that. And then divisible by 4. Well, this right here. There we go. So that's a lot easier. We're going to keep what I have down here, but I'm going to put it as like a side thing because, yeah, that's a lot easier, man. That's way easier. I'll put it like in the back. That's funny. I definitely feel confident that the other ones are like, you're not going to find another version of that. So 13. Next up. Sorry about that delay. 13. I'll be honest, I don't know my times tables, my multiplication timetables past 12. That's when I stopped learning it in school. So I had to look these up. I know them now. But I had to look them up prior. So what do we want to do here? Well, if we multiply this number by 4, then we can get 400a, 40b, and 4c. Well, that seems to be a pretty decent middle ground because with 40, we can take out 1b, which is not bad. So 4c we're going to have to keep, and then 10a we can take from 390. So not half bad. This is not too difficult to remember. 10a plus b plus 4c. Simple. So 10a in this case would be 2 for 273. B is 7, and 4 times c, c in this case being 3, is 12. So 20 plus 7 plus 12 is 39, which of course is divisible by 13. Simple. Next up we have ABC divided by 14. Remember, not ZABC, just ABC. Decided this time that we're going to multiply by 3, so we can get 300A, 30B, and 3C. And that will give us 6A plus 2B plus 3C. And the reason why is so we can take the 6 out of 294A, and that will, that's where we get this 300A from. And we can take 2 out of 28B, which of course 28 is from the 30 here, and 28 is divisible by 14 along with 294. Obviously, that's the reason I chose the numbers. So if this side will always be divisible by 14, so as long as this is divisible by 14, you're G to go, good to go. Here's an example: 364. 6 times 3 is 18. 2 times 6 is 12. 3 times 4 is 12 as well. 18 plus 12 is in fact divisible by 14, as you can see right here. It is 14 times 3, in fact. So because this number here, this 6a plus 2b plus 3c is divisible by 14, then the whole thing is divisible by 14. So there you go. A, B, C. So, divisible by 17. Because, of course, 15 and 16, we're going to skip 15 and 16 because we already showed how that can be applied for all numbers earlier. 17 being a prime number, you know it's going to be funky, and it is very funky. I tried my best to keep the numbers small, so I went with 7. The multiplication table being 7 this time, and that gives us the ability to have 700a plus 70b plus 7c, which is about as small as I could find it. So that gives us 697a plus 68b. Both of these numbers are divisible by 17, so as long as these numbers are divisible by 17, you're good to go. So here's an example, 561. Is it divisible by 17? No way in hell you know that off the top of your head, but now you can relatively easily find out. So 3 times 5 is 15, 2 times 6 is 12, and 7 times 1 is 7. "15 plus 12 plus 7 is 34. 34 is 17 times 2, so it is indeed divisible by 17. And last but not least, 19. Look at this, 19. Isn't that crazy? Actually, I don't know if I want... Hold on. Yeah, I think that's how I want to space it out. This one's actually not too crazy. It's just 10a, b plus 2c. Relatively simple. We multiplied this here, by the way. I didn't write this down, so I'm going to write it down now. We multiplied this by 2, so that gave us 200a plus 20b plus 2c. So what we did here is we took out the 10 of the a's here, so 10a here, and we took out 1b, and then obviously we kept the 2c, because both of these numbers here are divisible by 19, obviously. So as long as this bold part right here is divisible by 19, the whole thing is. So as an example, as I like to do, 247, 2 times 10 times 2 is 20. B times B is just 4, sorry. We don't multiply by anything. And 2 times C is 7. Sorry, which C is 7, but 2 times 7 is 14. 20 plus 4 plus 14 is 38. 38 is 19 times 2. So there you go. So I came up with these by myself. I mean, can you tell, considering I didn't even think about the fact that 12 is actually like really easy. A little bit of a dunce there on that one. But that is all you need. That there you go. So up to 19. I don't know how often you're going to need to know whether or not a number is divisible by 19, but up until 19, you have a relatively easy method to be able to find out whether or not a number you're looking at is divisible by that number. These are all decently small numbers. Like none of these numbers are more than 10. And 10 obviously is an easy number to multiply. It's just add a 0 at the end. So I tried to make it as easy as possible, and I feel like I did a really good job. I hope you guys enjoyed. Take care, peace, and if you want to, check out the video in the description. A, which should be the divisibility rules, and B, my creating this video, basically. The video where I went through and created this.